guys, welcome back to Up Tea Time for another demonstration. Today we are going to be looking at hyperbola curve. Hyperbola curve. Now, I have found a question from a CXC 2006 paper that I'm going to attempt doing today. But before I start, let me just introduce you, if you're new around here, to how I do things. The left hand screen is my AutoCAD screen where I do my information screen. So let's proceed. Now I'm going to read the question, and the question says, using the focus method, draw the curve of a hyperbola with the eccentricity of ratio 5:3. The distance from its vertex to its focal point is 25 millimeter, and from vertex to directrix is 15 millimeter. So some terms were thrown around there, like the vertex, the directrix, the eccentricity, and the focal point. So let us attempt to put this into AutoCAD now. And I am going to draw this. I'm on my construction layer, which I usually start off. And I always start off most drawings. Turn on my ortho, which is my F8. I usually start off most drawings like this. That's the first two things I normally draw. The reason being is so I can offset in any direction, north, south, west, or east. But today we are going to be starting off making this line here our directrix. So I'm going to label this line as my directrix line MTEX. And I am going to just place the word Direcctr, Directrix. All right, good. I'm just going to rotate this now, so that this would be RO to rotate. Good, cool. So that fits there nice and snug. So that's my directrix line, and I'm going to put that in the proper layer. Text there, where it should go. Now, what did they tell us? Let me just zoom in here and read now. Alright, it says the distance from, okay, let me maximize this, and let me just zoom in. So it says, using the focus method, draw the curve of a hyperbola with the eccentricity of 5:3 ratio. The distance from its directrix to its focal point is 25 millimeter, and from vertex to directrix is 50. So we already placed the directrix in, so we got to now offset 15 millimeters to get to the vertex. So let me just minimize that and maximize this now. So I'm going to offset, O to offset. 15 millimeter is my distance. And yeah, and this line is going to be my vertex line. So I'm going to actually put this as a hidden line. Let me just move this note over here. Directrix over here, and we're going to call that vertex. Vertex. Just move it slightly off of the line. Oh no. Cool. Then we need to put in now the focus. It says the distance from the vertex to the focal point is 25 millimeter. So I'm going to insert that now. So from the vertex to the focal point is 25 millimeter. Offset 25 millimeter. And I'm going to make this line construction line and call that point here on the base. That's where my focus is, right? I'm just going to move this text over here, and I'm going to call that focal point. All right, I think we have everything now in its proper position, and I can just, so I'm just going to call this point F, because this is where my focal is, my directrix, and my point F. Let me put point F into the proper layer. Right. So this is the question setup. I am going to place some dimensions here so that you guys following can see how I set up this problem. Just move down the text ever so slight. Right, so things read better now that they're closer to the line. Trim off here. Trim. All right. So we got our directrix, and the distance from the directrix to the vertex is 15, and from the vertex to the focal is 25 millimeter. Now we need to find the point of eccentricity. Our point of eccentricity is going to be found on our vertex line, and let's read here and see what they say. Right. Where do they use this word eccentricity? They use it right here after hyperbola with the eccentricity of 5 to 3 in a ratio. Now, if we look at these two numbers here that are in millimeters, we have 25 and we have 15. So if we were to just, you know what, I'm going to scribble on this paper and just show you what I'm talking about. So we have 25 millimeter, and we got 15 millimeter, right? Yes, and they are positioned exactly how I want them to be positioned. And we got, if we do this between them, we get to see the ratio 5 to 3. How do we see the ratio 5 to 3? If I were to put a number here like 5, and then come here and put 3. So you guys can look and see that there's a correlation between things here. What do I have to do to 25 to get it to 5? Well, I'll have to divide 25 by 5 to get it to 5. And I would have to then divide 15 by 5 to get 3. Alright, so that is how this eccentricity of ratio 5 to 3 matches back with 25 and 15. Because if I were here and I wanted to get 5, I would have to divide 25 divided, so we can just use my divide sign, oh, I don't like this, by 5 equals 5, right? Then if I came here, divided by 5 equals 3. So essentially, I said all that to say that the numbers 25 millimeter and 15 millimeter matches back with the eccentricity of 5 to 3 ratio, now that we can see it here. Alright, so I'm going to clear this now, and I'm going to show you what we do with that information. Now, where did we measure the distance from the vertex to the focus. We measured it right here at this point, and it was 25. Now, for me to find my eccentricity, I need to use the same 25 also, and the same 15. 15 is installed right here at the directrix to the vertex, and the distance from the vertex to the focal point is 25. But we need to find the point of eccentricity. I suggest you guys open a circle at this point on the vertex line, where the vertex touch the baseline here, where I am, and open it to 25 millimeter, the same distance from your vertex to your focal point. And where it touches above here on the vertex line, that is our point of eccentricity right here. This is our point of eccentricity. So I'm going to label that now. And I'm going to remove the circle. What I can do is, let me put that into my text there. And I'm just going to call that point E. You know, that is my point E, which is my eccentricity. Right there. Probably put the vertex label up there so that we can see this whole line is the vertex. So that is my point E. What do I do with my point E now? Seeing that we're trying to solve a hyperbola curve or create a hyperbola curve, E goes all the way down. I need to connect a line from E to my baseline. So I'm going to do that in construction. L for line. That's how I activate my line command. And E goes all the way down to the directrix at this point here. Now, I need to make a division from E. I need to create a line from E, point E, which is the eccentricity, to some distance over here. What I'm going to do is just pull this back to there. Yeah. That's the distance from E to some distance over here. This distance can be any distance. You can make it any distance, but I recommend don't make it too long. Right now, my distance is at 124. Yeah, I think that's a good, nice figure there. And I'm going to divide that line into 6 equal pieces. Div, touch line, and type 6 is the number. These are my 6 pieces. What am I going to do with these pieces? I'm going to label them first. That's piece 1, copy, 0, that's 2, that's 3, 4, 5, and then the last one is 6. Alright. And after I've done that, I'm going to place vertical lines at these points, at these 6 points that I've just created. I should probably just put a point at number 6 so that we can all see what's going on. And you know what? I'm going to put these as I go down into the proper layers too. So I generally draw everything on my construction layer, and then I just transfer to the appropriate layers as I am drawing. So seeing that we have here a line by the focus, I'm going to copy that line over to 1, over to 2, over to 3, 4, 5, and then 6. I'm going to remove the focus line because I already have the focus point, and that's the more important thing. I don't want to confuse my different points here. Now, what do I need now from here? I need to start measuring. I need to connect this line here, this diagonal line, to my last point, my last line, which is 6. So I'm going to fill it to do that. And that's what happens. And I'm going to extend all these lines to touch this diagonal line here. So EX, extend, touch these lines. And from right here, I'm going to trim this one. All right. So all my lines that I have, my 1, 2, 3, 4, 5, 6 lines, all touch and stop at my diagonal line here. What am I going to do at this point? I'm going to take measurements from my base, DIM, and I'm going to record the measurements from my baseline. This is my baseline here, and I'm going to take measurements from the baseline up. Just going to move the word focal over to where it is now, focal point here. And I'm going to take measurements, so I'm going to use the command DIM so that my measurements are recorded from point 1 all the way up to here. And that distance is 59.51 from points 2 at the base all the way to where it intersects the diagonal line. Points 3 to the diagonal line intersection, point 4 at the base to the diagonal line intersection. Okay, so before I go any further, I'm going to just make sure that I place these into the proper layer. That is should be on the dimension there. Look at that, very good now. Now that I have all of the measurements from 1 to 2, 1 to 6 recorded, I'm now going to plot these. And all these measurements now need to be plotted from the focus point, which is down here. So how am I going to do that? I'm going to hit C to draw a circle, and at the focus, the first point that I'm going to be plotting is point 1. So I'm going to open up my circle to 59.51. That is the dimension that I was given. And where it interacts the line, we place a point. So I'm going to put my points on my text layer. That's my first point above, and then there's my point below. It needs to interact the line on 2 points. So that is in, I can delete that. I no longer need that circle. So again, we plot all our points at the focus. So that was point 1 finish. Now I need to plot point 2, or plot the dimension to point 2, which is 94.01. So C to open up a circle. I connect the start at the focus, and I open up my circle, and I'm opening it up to 94.01. There's a point where it intersects line 2 above and below. Alright, points 3. So circle again, and the dimension I'm looking for is 128.52. So 128.52. Okay, let's see how that works out. Yeah. So the point below, I'm going to have to, extend the line to draw it in. That's not a problem. Good. Remove the circle. So I've done 3 points already. I'm going to go to point 4.4. I'm looking to punch 163.02. And I'm creating my circle, 163.02. Whoa, we are right here. There's a point there. And then you can place the point below. Cool. Remove the circle now. Let's proceed. So I'm looking for a circle at 197.53 on my focus. that number again, 197.53. Place my point above, place my point below, remove my circle. Now the last circle that I have to draw is 232.03. So that's 232.03. That's the dimension, and it interacts or intersects with the point with the line 6 there, and I just need to extend this line downward so that it can touch the circle there. All right, so I got in all of my points now, and I can see them there. Man, that looks good. For this one, I'm going to have to remove the title block because it's not going to fit into a title block space. And I'm going to turn off my construction layers. I'm going to turn off my dimension layers. And I'm going to get onto my outline there, and I can see the points that I need to plot. Now there's one more thing that I need to do. So I'm going to turn back on my layers, and I need to place, okay, a point here. Right here. So that when I'm drawing my curve, I can snap it in there. This place here where the vertex meets the baseline. Okay, so I'm going to start plotting now. So I'm going to turn off my layers that I don't need. By turning off these light bulbs, construction goes off, dimension goes off, and yeah, I can start plotting. I'm going to use the spline, SPL, and that activates the command for spline. This is what I use to draw all of my freeform curves. And yeah, I come here. And what I'm doing is I'm just going through all the points at the below, starting from 6, 5, 4, 3, 2, 1. And when I get here, I snap it dead on the baseline, where the baseline meets the vertex. And from there, I then plot the above points now. 2, 3, 4, 5, 6. When I get the last point, I hit enter. And because I know that I am done. Yeah, good. And that there is our hyperbola curve. What I like to do is I like to just hatch. So I'm just going to close the shape and place a hatch in, just for presentation purposes. So place a hatch there, and I'm going to go for my signature hatch, which is J wood. Now that's too thick, so I'm going to change that to 10. I think 10 looks good. And I'm going to turn on my layers. Remove this line, turn on my layers now. So I turn on the construction layer, turn on my dimension layer, so that you guys can see my full construction, even the dimensions that were recorded. So recapping again, this is my vertex. I'm now going to extend this line to here because it serves its purpose there. This is my vertex line here in the middle, which also you would find my eccentricity, my point of eccentricity, which is very necessary for creating this hyperbola curve. This is my focus point, or my focal point here. And this is my hyperbola curve. So what I'm going to do before I shut off this session is I'm just going to label this curve now as hyperbola curve. Okay, I thought I was in my multi-text box. Hyperbola curve. So I've drawn it on my hatch layer. That doesn't matter because I can just drop it into my text layer and voila, it's there. So I'm just going to bring that to there. And we know that's the hyperbola curve. I think I'm just going to trim some things before we close off this session. I hope you guys understood this curve, hyperbola. And that's it. I think if I want to turn off the hatch so we can actually go on to a different layer. That's something that's a bit tricky if you don't understand. Let me turn off my dimensions because and the construction line. Yeah. So that's the hyperbola curve there. And let's say we wanted to put a tangent to this curve. Just find any point on the curve and create a tangent, right? You should be able to do that. And that's the last thing we're going to do to this hyperbola curve. So I'm going to turn back on my construction lines. And I'm going to choose a random point. I think I'm going to choose this point right here. Yeah, this looks like a nice random point here. Oh, it's not even letting me. Okay, I know why. Because it's not going to snap. So I'm going to take off my object snap for this one and take off my ortho mode so that I can place a point anywhere I choose to without it telling me any or without it restricting me. Oh, it's still restricting me. Interesting. I don't know why it seems to be homing in at specific points. I don't know. Can I not just drag that point and put it there? Alright, that doesn't seem to be working. So what I'm going to do is just draw a line to cut the curve at where I want it there. And guys, this is going to be my point. Probably I can now put in my point. Nope. Don't know what's the problem. It should go in now that I've turned back on everything. Yeah, perfect. So you see, you got to know different methods to doing something. So I just wasn't able to snap to this direct point here, but I had to place a line to intersect the curve, and then I was able to place a point there. All right, so that is my point that I am going to be creating a tangent at. So what do I need to do? Well, first thing, I recognize the point, and I just got to label it. So let me just call that point R for argument's sake. And I am now going to connect a line from point R to my focus point, which is right here. Now when I get to my focus point, I need to create a 90 degrees from this line and send it directly back to the directrix. How do I create a 90 degrees from this line that has just this angle line touching the focus? Well, the old school way, which is to create a circle, any size circle. I'd probably use a circle that size, that's a good size. And grab the line that you just pulled to the focus point and pull it right through the circle until the perpendicular symbol appears right there, and then connect it like that. And then we are going to trim the circle. The idea is we are trimming a full circle, we're dividing it in half. That's the idea. So we're trimming half this circle, and this is the half we don't want, and that goes. Now that we have half a circle, which is 180 degrees, we now need to find the center or the midpoint of the circle, which is 90 degrees. This is the midpoint here that I've now touched. A triangle is over. Connect that to the focus point. And from there, this line that has been connected, this is our 90-degree line here. So we can actually trim this part of the circle so that all that would remain is our 90-degree segment. And what am I going to do with this line? I need to extend this line to the directrix now at this stage. So I'm going to touch this line, touch that line, EX, extend, that's the command I want, and voila, I've just extended that to the directrix. Now I'm going to create a point here. on my Directrix, and let's call that point. Let's call that, I don't know, call it RP. Just call in random letters. That's point P. And let me connect a line from point P to point R. And that's our tangent. But I want you guys to see this line that it goes right through. So I'm going to create some back line over here and then just extend that line, which is PR, that back line. And there we have it. That's our tangent line. And I'm going to write the label tangent there and make sure that it's aligned with this line. Because quite a few people have been asking me how I get my text to align with lines that I draw. Right, so just justify, middle, center, MC, and that's that. And now I'm going to go rotate, select the text, select the object, select the base point. Yeah. Then hit R for reference, enter, and I'm going to reference there. So I just do that, rotate it like that, and then just move it. Yeah. And that's it right there, guys. You just bring it off right there. Cool. Put down the respective layer, sorry. And I'm just going to increase the size here. So we're just going to increase that to about 8. Tangent. And that's the tangent line. So that's how we create a tangent line to a hyperbola curve. And this is our tangent point here, point R. I'm just going to put point R and point Q in text there. So guys, this is it. This is how we create. We don't need this line past here. Let me just create a line so I can trim. Cool. Zoom extents, and this is our project finished there. So this is the hyperbola curve, answering the question, and I have also done a tangent. Tangent wasn't part of the question to attach a tangent line there, but I just wanted to do that so that that's a possible question that can come on a paper, on an exam paper, or even a question that you can actually use if you want to create your SBA. You want to create your technical drawing portfolio, you can use that question there. It's up for grabs. Yeah, just let me just reread the question. Using the focus method, draw the curve of a hyperbola with the eccentricity of 5 to 3, that's a ratio. The distance from its vertex to its focal point is 25 millimeter, and from vertex to directrix is 15 millimeter. And the question is for 20 marks, and it was taken from a CXC 2006 paper. All right, guys, I hope you understood. Yeah, what I just explained there, that is hyperbola curve. And if you like this demonstration, you can subscribe, hit the like, and share it with others that you think would benefit from this knowledge. Now, thanks for watching. I'm out.